If a plus 1 over a equals 1, b plus 1 over b equals 2, c plus 1 over c equals square root of 2, and d plus 1 over d equals square root of 3, then what is the numerical value of this expression a times b times c times d raised to the power of 12 times b? Now pause the video right now and see if you can answer this kind of question. And of course, if you're done, post your answer in the comment section down below. Now let's see if you got the correct answer. So given these equations, our goal is to find the numerical value of a times b times c times d raised to the power of 12 times b. Alright, now let's answer this question. First, let's get the first equation. We have a plus 1 over a equals 1. Now here, a is in the denominator, so technically a is not equal to 0. Alright, so let's multiply all of this term by a because we know a is not equal to 0. This is legal. We have a squared plus 1 equals a. Rearrange some terms a little bit. We have a squared minus a plus 1. Now, since a here is not equal to 0, so again, multiply all of this term again with a. So we don't multiply both sides with 0. Now, using the previous equation, a squared minus a plus 1, if we subtract 1 on both sides, we get that a squared minus a is simply equal to negative 1. Now, why we do that? Because if we factor out negative 1 in this expression, we have something like negative of a squared minus a, which is this term, this expression. And we know this expression is negative 1. So we can replace this with negative 1. Negative of negative 1 is positive 1. It follows that a cubed is negative 1. Now we know the value of a cubed is simply equal to negative 1, given the first equation. Now, let's get the second equation, b plus 1 over b equals 2. Again, b here is not equal to 0. Now, this is allowed to multiply both sides by b. And then rearrange some terms a little bit. Now, this quadratic equation is what we call a perfect square trinomial because we can factor out this nicely as b minus 1 raised to the power of 2. And since we want to find the value of b, we can simply get the square root on both sides. So we have b minus 1 equals 0. Technically speaking, b here is equal to 1. So given the second equation, we know that b equals 1. Now, let's have the third equation, c plus 1 over c equals square root of 2. Again, c here is not equal to 0. Now, what we're going to do here is to square on both sides to eliminate this square root. Now, on the left-hand side of our equation, if we expand this, we get something like c squared plus 2 plus 1 over c squared. And on the right, we have 2. Now, subtract 2 on both sides, we get that c squared plus 1 over c squared equals 0. Now, if c is not equal to 0, c squared is not also equal to 0. So we can multiply both sides by c squared. So we have c raised to the 4th power plus 1 equals 0. Subtract 1 on both sides, we get that c raised to the 4th power equals negative 1. Finally, for the fourth equation, for the last equation, let's get this. And we know d here is not equal to 0. Now, to solve for the value of d, what we're going to do is to cube on both sides. Alright, now the left-hand side of our equation, we will have d cubed plus 3d plus 3 over d plus 1 over d cubed. And on the right-hand side, we have 3 times square root of 3. Now, rearrange some terms a little bit. We can factor out 3 in these two terms. And take note, this d plus 1 over d is simply equal to square root of 3. Given the first equation. So, we can replace this with square root of 3. And if we subtract 3 times square root of 3 on both sides, this is 0. So, we have d cubed plus 1 over d cubed equals 0. And since d is not equal to 0, d cubed is not equal to 0 also. So, we can multiply both sides by d cubed. So we get d raised to the 6th power plus 1 equals 0. It follows that d raised to the 6th power equals negative 1. So now, we can now find the value of our equation, a times b times c times d raised to the power of 12b. First, let's use the value of b because we know b is 1. So, we trim our expression to a times c times d raised to the power of 12. Let's use some laws of exponent. So, we can rewrite this as a raised to the 12th power times c raised to the 12th power times d raised to the 12th power. And we can rewrite this also as follows. We have 12 3 times 4, 4 times 3, and 6 times 2. Alright, so let's focus on this result. And finally, we can now use the value of a cube, c raised to the 4th power, and d raised to the 6th power. If we use all those values, we get negative 1 raised to the 4th power times negative 1 raised to 3 times negative 1 raised to the 2nd power. Simplifying this, we have 1 times negative 1 times 1. Simplifying this again, we have negative 1. Therefore, given this 4 equation, a plus 1 over a equals 1, b plus 1 over b equals 2, c plus 1 over c equals square root of 2, d plus 1 over d equals square root of 3, then the numerical value of the product of a, b, c, and d raised to the power of 12b simply equal to negative 1. And as always, we are done.